systems with three variables. Before we've done them with 2 using graphing, substitution, elimination. Now we're going to do it with 3. We're not going to do graphing because that would be a pain. Right. Do you want anything else up with? Okay. Okay, so we got some I cans. I can solve a system of 3 equations with 3 variables, and I can identify the variables and quantities represented in a real-world problem. Hopefully you'll be able to do those in like 50 minutes. So, like I said, we have 3 variables, x, y, z, and we are going to solve this system. Notice we have 3 equations, not 2, using either elimination or substitution. This one tells you to use elimination, but sometimes you just gotta think of what's best. A lot of times start with elimination and then use substitution later. We remember how to eliminate, yeah? Okay. So, just like before, I want to find the easiest variable to eliminate in all 3. I want one that has no number out front or a negative 1. So, what variable should I eliminate? Z. That is the one we're going to eliminate. So now I need 2 pairs of equations to help me eliminate that one. So one's going to be repeated. So I'm just going to rewrite these right down here. The first one, 2x minus y plus z equals 4. And x plus 3y minus z equals 11. Okay, so let's do that one first. If I'm going to eliminate z, am I adding or subtracting? Adding. Good. So 2x plus 3x gives, or 2x plus x gives me 3x. Negative y plus 3y gives me 2y. What happens with my z's? Cancel. And then 4 plus 11 gives me 15. So far, so good? Yes. Okay. Now, I'm going to take, so that was those 2. Now, I'm just going to take these 2. You could use top and bottom again, whichever one. Just don't repeat that one, obviously. So I'm going to take x plus 3y minus z equals 11, and 4x plus y minus z equals 14. You don't have to rewrite them if you don't want to. I just think it's cleaner, easier. So with this one, am I adding or subtracting to cancel z? Make sure we cancel the same variable. Subtracting, good. So if I have x minus 4x, I have how much x? 3x. 3y minus y.
Negative 3x.
You're right, my bad. Negative 3x, sorry. Plus 2y. What happens with my z's? Cancel. And then 11 minus 14, negative 3.
Could you multiply one of them by positive?
Yeah, if you, yeah. You can multiply this one by negative 1 and then add. That's fine. You should end up at the same place. You don't like negatives? Okay, are we okay so far?
So you just pick any 2.
Any 2 that are the easiest to cancel. Out of the 3, yep, you have to have 2 pairs. So one's going to be repeated.
So if you did the top and middle one, you can do like the top and bottom.
Yep. Okay. Now what we're going to do is write our 2 red equations and solve those. So we're pretty much back to what we know how to do. So we have 3x plus 2y equals 15. I'm just copying these down. And minus 3x plus 2y equals negative 3. So
3's cancel, the X's cancel.
Well, it depends what you want to cancel, right? Do we want X's? That's fine. We can do X's. So am I going to add or subtract? Add. Do my X's cancel? Yep. 2y plus 2y gives me 4y. 15 plus a negative 3, 12. So how much is y?
3.
3. So y is 3. So there's one variable. Okay. Now you can stick this back in here, here, those two same equations up here. I like to just put it in the top one. I don't know, I just think it's easiest. So we have 3x plus 2, my y is 3, so I'm plugging in my 3, equals 15.
3.
Oh, chill. 3x plus 6, 15. 3x equals 9. X does indeed equal 3.
Once you put that, we're done. And step 4.
What? Chill. Hang on.
Okay.
Are we okay so far?
Yes.
Yeah?
Yeah.
Okay. So then it says step 4, substitute solutions from step 3 into one of the originals. That'd be all the way up top. Okay? How about just the top equation? Does that work?
Yeah.
Okay. So that very top one, we have 2 times x. Do I know my x?
3.
Yep, 3. Minus my y, which is 3, plus z. I put a line through them because they kind of look like 2's. Equals 4. Then we just gotta do algebra. We got 6 minus 3 plus z equals 4. 6 minus 3 is 3 plus z equals 4. How much is z?
1.
1. Then the very last step, just kind of like before, I need to write them as an ordered triple. So I have parentheses, my x, 3, comma, y, 3, comma, z, 1. And that is my solution. Pause, don't turn the page. Ooh, go back. How do I know that it's right? Check it. Okay. So it should work here, right? 6 minus 3 plus 1 is that 4? Yeah. 3 plus 3 times 3 is 9. So 3 plus 9 is
3 plus 1.
3 plus 9 is 12.
Oh.
minus 1.
11.
11. So it works here. 4 times 3, 12. Plus 3 is 15. 15 minus 1, 14. Are we geniuses?
No.
No.
Hey, yeah. Okay, so 3, 3, 1 is for sure our answer. Questions? You can turn the page now, yeah.
It doesn't get harder than this.
Yeah, a little bit. It's not stuff you don't know. It's just a little bit harder because there's 3. Alright, so this time I have my 3 equations, 3 variables. Is there any one variable that's easy to cancel on all of them by elimination? None of the same coefficient, right? No same number out front?
Yeah.
So, I mean, I'm going to recommend we don't cancel z. You want to cancel x? Okay. We'll do x. I heard x first. So we're going to cancel x. So, I got to pick 2 pairs. We'll for sure do top and bottom because those cancel easy.
Top and middle.
And then top and middle? Okay. So then when it gets down to these, I'm just gonna quick copy these down so that we can see them nicely. I'd recommend recopying them, but that doesn't mean you have to. Okay, let me know when we're good.
Just that.
You want to say it right next to Maddie?
Right.
Do you want to introduce your student?
This is Wakaba. Just from Japan.
Welcome to math class. What? Okay, we good?
Yeah.
Okay, first one. I'm gonna cancel x, we said. Add or subtract, cancel. What?
Oh,
Yeah.
I have it the other way.
Yeah.
Just kidding.
Add this one. X minus x cancels. Y plus a negative 2y gives me
Negative one.
negative y. 2z plus z gives me 3z equals 13. What's my problem with the next one? They don't straight up cancel, right? Yeah, I gotta multiply by 2. You wanna multiply by 2 or negative 2? Negative 2? Okay. So, I'm gonna just multiply out and I'm gonna write it under, okay? So, negative 2x minus 2y minus 4z equals 6. Negative 6. Sorry. Nice catch. So this times negative 2 is right there. Add or subtract, cancel x? Add. X cancel, y plus negative 2y, negative y, 3z minus 4z gives me a negative z, and 7 minus 6 gives me 1. So far, so good? Yeah? Okay. Move it up a little bit. So now we're just going to rewrite our red equations. Negative y plus 3z equals 13, and negative y minus z equals 1. Do what?
No, all you have to do is do a minus, because that would be negative y plus 1.
Perfect. If I subtract negative y minus a negative y, that's like plus, right? Negative y plus y, those cancel. 3z minus a negative z is like adding 1, so we have 4z, and then equals 12. So how big is z?
63.
How about 3? Now where do I go?
You go to the red equation.
To the red equation. Doesn't matter which one. How about this one? Or do you not like subtracting?
Fine.
It's fine. It's
We gotta know how to do
It's
it.
fine.
We gotta know how to do it anyway.
Negative y minus, instead of z, I'm going to write 3 equals 1. Add my 3 over. Negative y equals 4. How big is y?
Negative.
Negative 4 divided by negative 1. my y is -4. Okay. That top equation okay? Okay, let's plug it in there. So I have x, I don't know, right? X plus my y is -4 plus 2 times my z is 3, and we want that to equal 3. So rewrite this, simplify. X minus 4 plus 6 equals 3. X plus 2 equals 3. How big is x? And second to last step, write it as an ordered triple. What number goes first?
1,
Second
2, 4,
and third.
3.
You guys sound so excited. Check it.
It works. I'm just gonna say it
We know it works in top one, right?
works.
2 times 1, 2. 2 minus 4, -2. 3 times 3, 9. -2 plus 9 is 7. Yup. We know it works there. -1 minus 2 times -4, so we have 8 plus, right? And then plus 3, is that equal 10?
Nope.
What?
Yeah, I'm kidding.
Did you go back down?
What?
Did you go back down? Go back down. Thank you.
Welcome. Okay, last one, ready? Let's go. Word problem. Woo!
Oh.
Yeah. Bruh. Alright. You manage a clothing store, but it's $6,000 to restock 200 shirts. You can buy t-shirts for 12, polo shirts for 24, and rugby shirts for 36.
That's not even real.
It is real. If you want to have twice as many rugby shirts as polo shirts, how many of each type of shirt should you buy? So, question. What are my variables? X, Y, Z.
X is t-shirt, Y
There
is
we
polo, Z is rugby.
We got X t-shirts, Y is polos, and Z is rugby shirts. I'm not even sure what a rugby shirt is, to be honest.
It's
Kind of like a
yeah, it's
I
like
feel
a,
like it's like striped. No?
yeah, it's striped like collar,
A collar?
just long,
Oh,
long sleeve polo.
look, we're learning something new every day. Alright, so my system of equations. Let's make a money equation first. How much are t-shirts?
Some of them are
Wait, no, 200.
$12.
Wait,
What? A t-shirt's
Twelve.
$200.
Wait, no,
Wow.
12x plus polos, how much?
24.
24y plus rugby shirts,
36.
36z.
If you look, we have multiples.
How much money do I have?
less than or equal to 6,000.
No inequality is just equal to. But yes. Equal to 6,000. Okay, so that's our money equation. So we've got rid of that.
And the 6,000.
And the 6,000, right, sorry. Okay, I got this 200 thing. What's 200?
How many you will need is 200 shirts.
Any combination of all three, right?
Except
So
you
all
have to
it
have
is-
twice as many rugby shirts as polo shirts.
Yeah. So all it is x plus y plus z equals 200, right? I want all my shirts, and I want 200 of them. Okay. So then, we got this last little tidbit that Maddie's talking about. I want to have twice as many rugby shirts as polo shirts. Well, that's z and y.
So 2 times 2.
2z. If I have one polo shirt, how many rugby shirts do I want?
2.
2. So isn't that 2y equals z?
Y is polo. And you want two.
Yeah.
You want twice as many.
Rugby shirts.
From
We should have 2 Z.
But if I plug y in here, if I have 2y, I get out 4, right?
See,
Yeah.
I trusted you.
But you did.
I
Second
was going
guess
along with
me.
them.
So you trusted them more than me, what you're saying?
No,
A little bit? A little bit.
a little bit. At least I was honest.
Okay. So, we good? Yeah? Let's go down to where we solve by elimination or substitution. Do we have anything that's nice? Unfortunately not. So, what I think the easiest is to multiply green by 12, don't you think? Yeah?
What would be easiest to do?
Or you want to multiply by negative 12?
No.
Positive 12, okay. So I'm going to rewrite our top one down here. 12x plus 24y plus 36z equals 6 out.
You sound so bored.
Are you bored? Better not be bored.
You want the honesty or you want the lie?
I want the lie. Alright, if I multiply that bottom one by 12, I got 12x plus 12y plus 12z equals 2,400. Okay. What should I do with those? Minus. What happens with x's? 24y minus 12y. 36 minus 12. 24. Z. 6,000 minus 2,400. 3,600.
I really should do this. It was like, said it right.
Oh yeah. This one's kind of nice because I have this bottom equation, the blue one that says 2y equals z. So what should I plug in for z? To this one. 2y, yeah. So I'm just going to plug this in. So that becomes 12y plus 24 times 2y equals 3,600. So then we do more simplifying. 12y plus 48y equals 3,600. Then we get 60y equals 3,600. And y is how much? 60. Okay. Where should I plug in this y60?
Red.
What if I plug it back into z?
And you get Z.
How much is 2 times 60?
121.
Where is it?
It's the easiest one to plug it into, right? Then we gotta go back. Probably that x plus y, right? Easiest one to plug into. Don't know x. My y is 60, my z is 120, and I want 200 shirts.
20?
20.
Are we geniuses?
Yes. So then with this one, instead of writing a triple, we'll write 20 t-shirts, 60 polos, and 120 rugby. If you check it, I checked it. They all work.
Could you multiply the 24 into
Can we see you
Yeah.
check
And
it?
cancel your Y's.
Can we see you check it?
Can you see me check it now?
Yeah.
You don't trust me, Jay?